Okay, welcome back, grade 11s. This is our last lesson for this chapter, and we're going to look at how to use modeling of graphs with now situations. And these situations usually take the role or the form of sound, light, tides, maybe being on a Ferris wheel, pendulums or springs, anything that has a repeated predictable motion usually can be graphed or modeled with a sine or cos graph. And again, remember that we're trying to model these situations with an equation so that we can then use that equation for future predictions to input other values. So the most common one you're probably going to see is either tides or Ferris wheels. So I think I'm doing a tide question, a Ferris wheel, and a spring question with you today. I might break it up into a couple of smaller videos, but we'll see how it goes. So in this first case, again, I hope you printed it, but if not, you should have copied it out. So you can fill it in along with me. Here we have a Ferris wheel, and here's a small picture of it on the side here. And it has a radius of 45 meters. So that's good to know. So that means from the center point out to the edge is 45 meters. So it's a pretty large Ferris wheel, obviously. And its center, so the axis, in other words, right? This is called the axis of the wheel. The axis is located 50 meters above the ground. So that's 50 right there. So right away, we know that this amount of distance right there from the ground up to where the edge of the wheel is, if this is 45 and the whole thing is 50, this must be 50 minus 45, or better known as 5. So 5 would be the minimum height that this wheel reaches, so it doesn't obviously scrape against the ground when it turns, and you probably need to get up on a platform in order to get on the ride. That would make sense. And then when you're at the peak or the highest point of this ride, you're at 5 plus 45 plus another 45. So this peak up here is not just 45 plus 45, because you have to add the 5 that you are off the ground just to get on it. So 45 is 90. 90 plus 5, you're at 95 meters off the ground. So right away, we know that the axis, the midline's at 50, the peak is at 95, and the lowest point is 5. So that right away gives me my max, my min, and my axes. So there's my A, there's my Q. Everything that I need for A and Q are right there. It also tells us something about how fast it's turning. So that tells us then about the period. So it says the Ferris wheel makes a complete rotation in 20 seconds. That's pretty fast for a wheel this size. This goes around once and it takes 20 seconds. So that means one complete revolution, one complete cycle takes 20 seconds. And of course, they tell you that expect the rider to get on the ride at the lowest height. So right here, that makes sense too. So most people are visual, so I suggest you probably do yourself a little graph. Might as well use this space here, where we're going to put time along the x-axis and height, again in meters, along the y-axis. Obviously 0 seconds. And then since it looks like it's 20 seconds to finish, why don't we go 5, 10, 15, 20. That would be one revolution. And then we can go 25, 30, 35, 40. That would be 2 cycles, right? 40 seconds. Again, the Y scale, we need to go all the way up to 95. So depending on how much space you have, 0 height is the lowest you can be. Obviously, it's not going below ground. I don't know how much space I'm going to have here, but 10, 20, 30, 40, 50, 60. So that was 50, 60, 70, 80, 90, 100. So I'm barely just fitting 100 in the space that I have. So if you do a better job or put this on proper graph paper to the side, you'll be able to spread out your axes even better. So let's graph. What does this look like? So the person gets on at the lowest height. So 0 seconds have gone on because they haven't started the ride yet. They get on at a height of 5 meters. Why did I put minutes there? 5 meters off the bottom of the ground. So that's 10. So 5 would be obviously halfway. Now, when are they going to get back to this point again? Well, it takes them 20 seconds to get back to that bottom car. When they got to sit down for the first time, it takes them 20 seconds to get back to that same height off the ground, right? So 5 meters again at 20 seconds, and again at 40 seconds if we continue, and we can go on for many, many cycles. Now let's think about, when do they reach the peak? So if it takes them 20 seconds to go around this whole thing, that means halfway they should be at the opposite end of the Ferris wheel. So at the opposite end, it should take them half the time it takes them to go around once. So if it takes them 20 seconds to go around the whole thing, at 10 seconds, they should be at the opposite end. So again, 50, 60, 70, 80, 90, 95 would be there. And I suggest that you draw the axes, so your midline, because it really helps you with the graphing of things. So the axis is located, right? The center of the wheel, the axis of the wheel, is located 50 meters above the ground. So instead of being at 0, 0, everything was shifted up 50. So at 50, I would draw a dotted line. So what happens then, a couple of your homework questions may have been similar to this. You're at a height of 5. You get back to a height of 5 20 seconds later. Halfway through, so 10 seconds, you should be at the peak, so a 95. But between 0 and 10 seconds, you're going to cross through your midline. And halfway between 0 and 10 is 5. So at 5 seconds, you should be at 50 meters, meaning 5 seconds, 10 seconds, 15 seconds, 20 seconds. At 5 seconds, you should be at 50, which is 5 plus 45. You should be at this height. You should be a quarter through the ride. And then also on the way down, between 10 and 20, halfway is 15. You should be on your way back down. So you should be at your new axis at a height of 50 above 15 seconds. So what happens is when you graph this now, you get your first cycle of your sinusoidal curve, right? So it's not a V, so it's still curvy, come up, hit the peak, come back down, go to the bottom. And then repeat. If I asked you for a second cycle, you would just repeat the exact same process. 20, 40, you finish it. That means at 30, you're at the max, 95. Halfway between 20 and 30 is 25. You're going to hit the middle. Halfway between 30 and 40 is 35. You're going to hit the middle again, but on your way back down. So now just join up, make it curvy, and there you go. So there's 2 cycles of our ride showing our height versus time on this Ferris wheel. So the first question you're always going to be asked is find an equation using a sign and then again using cos. So it wants us to do it both ways. It doesn't matter for A, K, and Q. Remember, they're both the same ways that you find them for either sine or cos. The only difference is how you go about finding P. So let's get our A value. Amplitude. We already know what the amplitude is from the graph, from our situation here. But just to show you what it is, amplitude equals max minus min, cut in half. The max is 95. The min was 5, and we're cutting that in half. 90 cut in half is 45. Well, we've seen that 45 before. This is the radius of the wheel. Obviously, our height off the ground is going to be cyclical based on how big the circle is. So the radius of the wheel gives us our amplitude, because this is our midline, the radius up, the radius down, right? Radius to the peak, radius to the trough. That is better known as amplitude. Then we're going to find our axes. Now we already know what our axes is, but using our formula from before, it's max minus amplitude, which is 95 minus 45. And there you go. That would be 50. And we already knew it was at 50. So there's our Q, there's our A. Next, we're going to find our K. K equals period. Oh, sorry, K equals 360 in our case divided by period, which is 360. Now, one period is 20 seconds. So it told us in the words how long it takes to get back to where we started from. So you have to read very carefully that it's not just telling you from minimum to maximum is 20 seconds. It's saying the whole thing is 20 seconds. So make sure you read very carefully as to the length of one cycle. So 360 divided by 20 is our 18. And that's very typical for a K value. And then, of course, we have to get our phase shift. So our P value, if we're looking for sine, we're only going to do it one way. There's no point, no purpose in doing it multiple ways. So we only need one sine equation and one cos equation. If we're going to do sine, we're looking for our 0, 0. Again, it's the beginning of the upward bump. This is not the beginning of the upward bump, right? This is the bottom. This right here is the beginning of the upward bump. That point right there. Again, where the curve meets the new axis, which is located at a height of 50. The beginning of the upward bump happens 5 seconds to the right. So 5 seconds right. That would be an option. So in that case, f of x equals 45 in the front, then a sine, then an 18. Now our x-axis happens to be time, so let's get rid of actually x. Let's call it f at t, our function in terms of time. Actually, the f could be then also replaced as h, so h at t, height in terms of time, equals 45 sine 18, t minus 5, because I picked right 5 seconds, so we're going to put a minus there because we want the person to go right, and shift it up 50. So I think that would be the most common version of a sine equation you're probably going to see. Now, if you wanted cos, what you're looking for is where did your peak go? Now, your peak is right here, so you could say 10 seconds right. Nothing wrong with that. Other people might actually choose the bottom and then no phase shift. So they might say 0, but it was reflected because we're now upside down. So I'm going to do the 0 option just to show you. So height in terms of time equals, again, 45 cos 18t, no phase shift, plus 50. But because we're starting down here instead of up here, I have to make that a negative in front of the 45. So that would probably be the most common version of the cos equation, because a lot of people don't want to bother with phase shifts if you can just start at either a peak or a trough. So in this case, we're starting at a trough, a minimum. Then it says, how high is the rider after 17 seconds? So t is equal to 17. Now it shouldn't matter which equation you pick. So what you're going to do is you're going to find h at 17, in other words. You're going to sub in 17 here, and you're going to work it out. So 45 sine 18, and then 17 minus 5 in this case, plus 50. Now you have to do BEDMAS. So 17 minus 5, pretend you didn't know that, and then go times 18, the K value. So we're at 216 so far. Take the sine of that, sine of 216, you get this negative 0.5 number. Then you times it by 45 in front, and then you add 50. So the add 50 is the last thing you do, and you get 23.5 meters, I think is our units. Now if you choose cos, h at 17 over here should be the same thing. Negative 5 cos 18 times, what was it, 17? Plus 50. Now in this case, you're going to go 17 times 18, but now you're going to take the cos of it, because it was a cos equation, times negative 45, and then you're still going to go add 50. And look at that. You should get the exact same answer that you would have gotten with your sine equation. Of course, you're only going to do it one way. I'm just showing you that regardless of which version of whatever equation you modeled, you should end up at the same thing. Now, obviously, we can go to our graph, find 17 seconds. So here's 15 seconds. 17 should be just a little bit past 15. Read up and read across. And what height do you get? So 17 would be about there. Yeah, my graph isn't that great. So I'm looking at mine being pretty low. My graph probably should have been a little bit higher in that scoop. But the equation is right. The graph ain't so good. Now it says find an equation for the motion of a rider if the graph begins when the rider is at the highest point of the Ferris wheel. So basically it's saying, what if we started at the peak? Started on top instead of on the bottom. So what happens to the equation, doesn't matter, sine or cos, if we're up here instead? So instead of getting on at 5 meters, what if they got on at 95 meters and then came down to 5 and then came back up? So the obvious point or method that people would say would be that the cos graph is going to start at the peak, right? Would start at peak, which means no phase shift, no reflection, because you're starting on top, which is what cos naturally does. So h at t equals regular 45 cos 18 t, you can put brackets around that if you like, and then plus 50. So that would be the most common version of the equation. Now, if it was sine that you picked, it would be, again, the beginning of the upward bump you would look for. But if we started up here instead of down here, the graph wouldn't be going up. It would actually be coming down. So if you pick sine, then the graph is coming down. What that means is that now we're going downwards first so that there's a reflection. The phase shift stays the same, so the same P. So whatever reflection you picked here, 5 seconds, it's still going to be there, but the loop would be coming down and not heading up. So again, the most common way for people to do it would be negative 45 sine and then 18 bracket t minus 5 units right, plus 50. And that's probably going to be, again, the most common version you're going to see. But again, there's so many other versions you could have come up with. So then we get a little more interesting, where it says, find the original equation, okay? So for the original equation, where again, we're back starting at the bottom, between the first cycle, between 0 and 20 seconds, when the rider is 30 meters off the ground. So this is an H number. We have to find T when H is 30. So again, it won't matter which equation we use, sine or cos. Why don't we use the cos one? Just looked a little simpler. So if you remember, the cos equation to start with was negative 45 cos 18t plus 50. So it's asking us to solve for t when the height gets replaced with 30. So now we're solving for our independent variable. And what we have to do is we have to start bringing things over. The first thing you're going to kick out to the other side is the 50. And of course, that'll be subtraction. So that's 30 subtract 50. So the 50's come over. Then you're going to divide both sides by negative 45 because that's attached to the cos. And that's what you have so far. So I kicked out the 50 through subtraction and I divided by negative 45. Then what you have to do is you have to remove the cos. And the way you remove the cos is by inversing cos on the other side. So what we're really looking for is the inverse cos of 30 subtract 50 divided by negative 45, and that's going to be 18t. So in your calculator, 30 minus 50 equals, divided by negative 45 equals the 0.44 number. Don't write it down. Go inverse cos right away. 63.6. Okay, so all of this is worth 63.61220004. Again, don't round because we're not finished. Now that's what this 18t is worth, because we still had the k, and if there was a p, we would still need to remove the p. But right now we just have a k. So now we have to divide by 18. So t is equal to, basically, if you want to see the whole thing written out, so what we just did in our calculator, so inverse cos of all of that divided by 18. So while it's all still sitting in your calculator, I'm not going to bother writing down the decimal. 3.53. All right, 3.53. So that would be seconds. Let's look at our graph. So when do we hit a height of 30? The calculator says at about 3.5 seconds. So find 30 on your scale. 10, 20, 30. Go across. We're only interested in the first cycle. So I hit 30 approximately here. Okay, so before 5 seconds. So that could be the 3.5 answer. But I also hit 30 over here. And the 30 over here isn't 3.5. So I need to be able to get my second answer. So I need to be able to use this space of 3.5, right? This is 3.5 seconds to go from 0, so the bottom of the peak, so the bottom, the trough, over to where we hit the height we're supposed to hit. I need to do that going backwards from the bottom, the next bottom. That's 3.5 again backwards this way would give me when I hit that same peak over here. So what is 20 minus 3.5? And you notice I'm doing it 20 minus 3.5, not 15 plus 3.5, because it was from the trough over, from the trough backwards and over to get our two answers on either side, once going up and the other time coming down. Because obviously we're going to hit a height of 30 on our way up and on our way back down. We're going to hit it twice per cycle. So we're trying to figure out all the times we hit that particular height. So we should get two answers, one there and one there. So 3.5, sure, makes sense going up, but what about coming back down? 20 minus 3.5. So time 1 is 3.5. Time 2, we're going to use our bottom number minus 3.5, which is approximately 16.5 seconds. So at those two times, with the first 20 seconds, we actually reach this height of 30. It says if the ride lasts 2 minutes. Okay, so if the ride lasts 2 minutes instead of 20 seconds, so 2 minutes is 120 seconds. So we're just still talking seconds. How many seconds does the rider spend above 72? So we're looking for a height of 72. So this is going to change our K. So we have to obviously put in our new K value. K is going to be 360 divided by 120 seconds now. So our K value is now 3 because the graph's been now spread out some more. And our new equation. So nothing else is pretty much going to change. I'm still going to keep it as a cos equation because I think that's the easiest. Because again, we started at the bottom. So negative 45 cos instead of 18 is now going to be a 3t plus 50, no phase shift. There would be a phase shift change for sine. That's why I'm choosing to stay with cos, so we don't have to think of a phase shift, because regardless of how spread out this is, we're still going to be always starting at the bottom here. So that won't change for cos. Sine, this point is now going to take longer. If it takes you now 2 minutes to go around, to get you to this point right here, which is where sine started, it's now going to take you 1/4 of 2 minutes, which is 30 seconds. So it's going to be a 30-second phase shift for sine instead of a 5-second phase shift for sine. So, and I didn't want to draw a whole new graph, so that's why I stuck with the cos equation. Now, stick in 72, and again, find your new t value. Now, in one step, I'm going to rearrange this. 72 minus 50 divided by negative 45, inverse cos of that, and then I'm going to divide that by 3. And that will give me my t value. So 72 subtract 50 divided by negative 45, inverse cos divided by 3. And I get approximately 39.8. So that means that I hit this height of 72 at 39.8 seconds. So 39.8 seconds after I get on the ride, I'm at 72 meters high. But I again hit it on my way back down. So just like before, you have to now figure out when do you hit it on your way back down. Well, we're going to hit it on our way back down 39.8 seconds inward from the duration of the ride, which in this case, instead of 20 seconds, is now going to be 120 seconds. So on your way back up, on your way back down, so 120 minus 39.8 is 80.2. So it's the same thinking as before. So in between these two times, so 39.8 less than or equal to t, well, it says above, so equal to or above, 80.2. So in between those two times, you are higher than 72 meters. All right, so a picture I know is a little more helpful. So I'm going to stop this video here. Go over it again if you need to. I know it was a lot. And then we're going to pick up in the second video with a spring question. So you can see different types of motion and how we model that.